All right.
Professor,
Yes.
are there any handouts for today I have to read from?
Do it again.
Are there any handouts for today I have to read from?
Oh man, I was gonna do an example of that question you had.
I'll wait for you.
Okay.
I just want to let you know.
What were? No, we're gonna work on the handout from last time. So let me do this real quick.
Do you have extras?
Extra what?
Handouts for today?
Of what? Sorry. All right. Let me. When we get to it, I'll. Yeah, okay. First thing I want to talk about is this though.
Okay.
Um, let me make this like this. There we go. Put little squares on them just so I don't get anybody complaining. Now it's not going to work the way I want it to. Dadgummit, Jeff. There. All right. Ignore the first guy. I changed part of it and it didn't work then. Are there any differences between those two series?
Where they start.
So I would accept two answers right now. Yes and no. Yes, because one starts at 1, one starts at 2, right? So on the surface, they look different. But what do I get when I plug a 2 in here? What do I get on the bottom? What do I get on the bottom? 4. What do I get when I put a 1 in here? What do I get on the bottom? 4. What do I get when I put a 3 in here? 9. What do I get when I put a 2 in here? On the bottom? 9. 2 plus 1 is 3 squared is 9. Yes? Is everybody with me?
Yes.
Do you guys remember transformations of functions? When you had a function like a parabola and you move it over, move it down, flip it, all that kind of weird shit. This is just a transformation. That's what I mean by shifting series. This is just shifting this function back 1. So look what the end did. Went back 1. Yes? I don't know if you guys remember this. If I have the square root of x plus 1, that just takes a square root function and moves it back 1. Because now I'm adding 1 to my inputs, they could all be 1 less than they used to be. Does this sound familiar at all? So once you learn shifting functions, it works for any function in the universe. That is a function. It is a function of n. Same idea. I need you guys to see this.
So that,
Go ahead.
so then would
Go ahead.
B would equal pi squared over 6 minus the first 3 terms?
Yeah, so there's a problem that tells
Start at
you
3.
this is pi squared over 6, right?
Yes.
So if I want to get this one, does this series, now I know they both have infinite number of terms. I know they do. But if you just talk about it on a lower level of just which one of these has more elements in a way? The first one, yes? This one, I mean not the first, but this one does, yes? So how do I, the sum of everything is pi squared over 6. What is this guy missing compared to him? The first term, and what is the first term? 1. So then the sum of this guy must be pi squared over 6 minus 1, because he's missing the first term. Do you guys see that?
Yes.
Now, there's another problem that has like this shape to it. I can't remember exactly what it was, but it was sort of like this. And all you have to do first is shift it. So if they gave you this problem, you shift it here, and then you do what we just did. So if there was an n minus 2, you would shift it up 2. You would make this go from 1 to 3. Okay, maybe. Maybe? Okay, maybe.
And then for the C part of that question, it gives us like 1 over 2n to the second power.
Totally. So, let's say, watch this. Let's say that this is 4. What does that mean? Yeah, when I add up all these sequence elements from an, I get 4, yes? So what would this be? 2, yeah. I'm just dividing everything by 2. So of course the sum is going to be half of what it would have normally been. In fact, since this is an infinite sum, does every element have something that's common? Does every element of the sum, what do the terms look like? A1 over 2 plus A2 over 2 plus A3 over. So even before I do that shit, I could just take a GCF out. I could take a 1/2 out. That feels a lot like taking a constant out of an integral. And what does that have to do with this, Jeff? Well, a freaking integral is just an infinite sum of rectangle areas, yes? That's why it acts the same way. Any constant multiplier in a sum I can take out. I'm just doing GCF. I'm just doing freaking algebra 1 shit. Now, it looks freaky as hell, but I want you to notice, a sum is just adding a bunch of terms. If they all have the same factor, you take the damn thing out. Yeah.
With the way it's written, 1 divided by 2n, that whole term squared, can you factor out a 2?
Wait. It's like this?
1 over 2n.
Like that?
Yeah.
Oh, okay. So what is this really?
1, put in the first term.
No, what is this really?
The bottom is double.
No, what is this really?
4.
4n squared. So what do you factor out? Yes. Okay, good. Yes. If you can get down to what is the constant factor? What is not constant factor? What's the common factor? There's the C word. The common factor amongst it, right? Then you can just take that out the way. In this problem, it makes infinite sense because if I could just make what I'm looking at look like this, I know I can base the sum on this, right? But this does, later this semester, the whole idea of what I just showed you with shifting stuff becomes huge. We're going to start to like combine different series, and they can't combine unless they start at the same index and they have like terms. So we're going to have to do, shifting is one thing we're going to have to do to make them kind of line up with each other. Okay. I just like to let you know that a little skill I'm talking about does come into play later. Okay. Is that decent? Did I start this recording?
Yeah, you did.
Because I forgot to record my earlier class. Anything else from homework stuff before we get back into where we left off? Okay. Did I showed you that survey last time, right? Okay, good. There's one class I forgot. I can't remember what it was. So last time, if there's no other questions, last time we started getting to 11.4, which is the comparison tests. This is an example of there's a certain skill you have to be able to kind of apply these ideas. And I talked about it in a very freaking high level conceptual, just no details. I just stood up here and hit my hand, which was great. It's like, thanks, Jeff, that makes a lot of sense now. But the whole idea was, if I have a sequence that's always bigger than mine, and it converges, mine has to converge, a series. Right? If I have a series that's always bigger than the one I'm looking at, and this guy converges, mine has to converge. It can't diverge. Okay. And if I have a series that's smaller than mine that diverges, then mine has to diverge. There's no other option. Yes? Okay. So what does that look like in terms of a problem we're going to get? So let's see. What if I had to figure out if, what you got, Jeff? Give me a moment. Yeah, let's do n squared. Yeah, sure, plus 1. Now at this moment, this is not P-series. Why is this not P-series? Yeah, because the plus 1, I can't put it in the form 1 over n to the p. I can't do it. But it's only off from a p-series because of the freaking plus 1, yes? So here's where students lose touch with this reality. I'm about to, but tell me, because this is almost a p-series, p equals 2, do you think this converges or diverges? Because what does the related p-series do? 1 over n squared, what does it do? Converge. It converges, yes? Because p is greater than 1. You guys agree with me? P-series kicks so much ass. Let p-series kick ass, yes? So I go into this knowing pretty well that this converges. So do I want to find a floor or do I want to find a ceiling?
Ceiling.
I want to find a ceiling because I know this converges. If I can find a series whose elements are always greater than or equal to this one, and it converges, mine has to converge. Because that would be a ceiling, it converges, I can't go to freaking infinity because it converges. Okay. Let me stop for a minute. Before I get too much further, here we go. In case anybody didn't get this handout last time. Here we go. Oh, it was on the back of this one. Does anyone need this handout from last time? On the back of it's got the comparison tests. You're welcome, Stu. Oh, that's awesome. I had 3 and only 3 needed. Take on. If anybody else needs it, too bad. Okay. Notice a couple things. Let me get a little more. Now we're getting a little more formal, so I want to get a little more formal. Everything we've been doing so far is about positive term series. The integral test, P series, all that kind of stuff is all about positive term series, and so is this one. It's got to be positive terms. It's got to, well, depending on which thing. So right now with ours, I want to construct, since the one we're given, I feel pretty strong that it converges. I want to find another series that has positive terms. I want this series to converge, and I need it to always be greater than this guy. Right? Now, this is kind of silly to say because we're talking about positive term series, so obviously they're greater than or equal to 0. Okay. So, what series do I want to compare this to? So this one, I normally say, if you write like this goes like 1 over n squared, converges, we want a ceiling. Okay, so I want to end up comparing my series to 1 over n squared or 2 over n squared, because 2 over n squared converges, correct? Are you guys with me? For example. So here's the thing. This is the part that feels like cheating. I'm going to construct another series. It's not given to me. I'm given this one. I'm going to do several steps. In fact, this one's going to be easy. I'm going to do one step when we're done. Some of them could require several steps. I want to modify the one I'm given. And I always want it, I want to find a ceiling, correct? So whatever I'm about to write here, what inequality symbol do I want between them? If I want this one to be a ceiling, I want this one to be greater than that one. So I want this one to be greater than or equal to that one. Do you guys see that? Okay. There are obvious pitfalls here. There are things students don't look at correctly. I'm constructing another series. I can make it almost anything I want to, but if you follow these 2 things, there's only 2 things that can happen, and I want you guys to know this, because part of this feels very amorphous. Like you could literally put anything you want to there, as long as it's true, but only certain things are useful. So watch this. There's only 2 things that can happen. Why is this not 1 over n squared? Stupid plus 1. If I take that away, does the resultant thing meet this requirement? Yeah. Is 1 over n squared bigger than that? Why? Because this denominator is bigger, so this thing is less than this. Do you guys see that? So there's a few things going on. You have to be able to identify what is, and sometimes I'll say it this way, what is this trying to be? He's trying to be 1 over n squared, but somebody put the damn plus 1 there. So I'm like, okay, this wants to be 1 over n squared. That tells me I want a ceiling. That tells me the direction I want these to go in. That tells me the changes I make better follow that requirement. So you have all these kind of like constraints you're giving yourself. So sometimes Just taking the damn thing away is all you have to do. Yes? So, does this converge? Why?
P series.
P series, P equals 2 greater than 1. So therefore, what does this do? Because of what? Because of the direct comparison test. I can't remember if I said that yet. These are direct comparison tests. Which again, math people, very creative. We said, oh, we're directly comparing thing. Let's call it the direct comparison test. So there's only two things that could happen. I need you to notice this. One thing is, I take away whatever's there, it makes it work. So what if I had this instead? What you got, Jeff? I don't know, man. Bump, 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 bump. Yeah, I like that. What is that trying to be? What is it trying to be? 1 over n cubed. Is everybody with me? There's a 2 there that somebody put there, and there's a minus 1 somebody put. It's trying to be 1 over n cubed. It's kind of like the same thing as taking away all the shifts. It's been shifted down 1, it's been doubled, but take them away, get 1 over n cubed. Yes?
Yes.
But so 1 over n cubed does what? Converges. So I want to find do I want to find a ceiling or a floor? Ceiling. Therefore, I know I want my inequality to do this.
Yes.
So I can go straight from here to this. So I start here. If I just take the negative 1 away, does the requirement that the inequality shows me, does it hold? Do I meet it? If I just take the negative 1 away, what did I just make the bottom become? Bigger or smaller?
Smaller.
Careful.
Bigger.
If I don't take 1 away, the bottom is now, and the whole thing gets smaller. So if I write this there, it's smaller than this. Damn it! Okay, you guys good? I need you to understand this. Because I'll let you in a little secret. When I was a student, I didn't do so well in Calc 2 for several reasons. There was a lot going on that semester. I had a horrible teacher, and he didn't explain shit. So now I'm like, later in life, I'm like, okay, holy shit, if he would have just said this, it would have made some change. There's only 2 things that can happen. I either take it away, if that doesn't work, and this is the part that feels like magic, I do this. I make like terms. Now think about it. If I want this to be bigger than that, I want this bottom to be smaller than this. And by the way, I got to change one little thing. Is this bottom, no, I'm cool. I'm good this way. Is this bottom always smaller than that bottom? This one time it's equal to it when n is 1. Do you guys see that? Mm-hmm. Otherwise, what's true about this bottom? How does it relate to this bottom? This bottom is always smaller, yes?
Yeah.
Do you guys see that? If I plug a 2 in here, this is 2 times 9 is 16 minus 1 is 15. If I plug a 2 in here, it's 16 minus 8. Yes?
Yeah.
That the bottom here is smaller. That means the whole thing is bigger. When I divide by smaller, I get bigger the way I want to. I want it to be bigger than that guy, yes?
Yeah.
The only 2 things that could possibly happen to make the inequality work is you take the damn thing away that you don't want there, or you replace it with like terms. Because now what does this become?
1 over n cubed.
And what does this do?
Converges.
Why?
A P series. P is.
Convergent P series. P equals 3 greater than 1. And therefore, what does this do? Converges because
DCT.
by DCT. Direct comparison test. It could feel like magic. It could feel like you're doing illegal shit. I just pulled this right out of my ass. Right? This just came out of nowhere. Why am I allowed to do that? Because as long as what I put here does 2 things. As long as it's bigger than this guy, and it converges. if I find any series that is bigger than the one I'm looking at and it converges, what does mine have to do? If any bigger one converges, mine has to converge. So I have so much flexibility. You guys, I've got to really internalize. You got all the flexibility. The only problem is if you go a little too far, you might end up with something that doesn't work. So you got to be careful. You want to keep it close to what's already there. Yes?
So in this case, if you did, would you be able to pull out the 1/2, or would that be harder?
I mean, you could, but it would make it a little weirder. So let me show you what I'm trying to say. Watch. Let me show you what if it would have been this. And then we'll do a few floors. We're only doing ceilings right now, but let's do a few floors in a minute. What if it was, actually here, I'll do a floor. No, there. 1/n minus 1. Let me write that again. Okay. So here's the freakiest this could get. Right? So if you pulled out the 2, it effectively, we'll tell you something. Oh, I went the wrong way.
Yeah. Let's do.
I was going to do a cube again.
Oh, okay.
No, we'll be okay. So help me out. What is this trying to be? It's trying to be 1/n. This diverges. So what do I want to find? I want to find a floor, which means I want my inequality to go this way now. I want to find something that's below the dude I start with. Do you guys follow? If did I do this correctly? If I take that away and make the bottom, if I take that +1 away and make the bottom smaller, which makes the whole thing bigger, damn it, this still doesn't do what I wanted to. I'll get there. All right, this is an example of a floor, and then I'll give you an example that I meant to give you. All right, real quick, let me do this again. If I take this away, if I put that there, it doesn't match this, yes? If I take that away, it makes the bottom smaller, makes the whole thing bigger. So what am I going to do instead? Those are the only two things that can happen. I can either take it away, or I can replace it with like terms. So in this case, replace it with n. So it's like terms. See that? And real quick, does this make sense? This is stuck at 1. So as n grows, this bottom grows faster than that one. This is going to be smaller than that one overall, right? If I'm dividing by bigger, then I'm getting smaller than this guy does. And what is this? And what does this do? Diverges because it's a p-series. Good Lord, Jeff. P equal 1, which is not greater than 1.
Yeah.
So what does ours do? Diverges by yes. You oh my gosh. I'm not drunk, my hand is. Okay. So let me try to create one that does what I was trying to do earlier. I want you to see how this gets slightly freakadelic. Oh, I can do it like this. Yeah, I can do it like this. No. I know. Hold on. Yes, I think this will do what I want. Yes, please do what I want. Okay. Oh, not quite. I need this to be square. There we go. I'll get there eventually. I think this will do what I want. Let's find out. Yeah. So no matter what, it's going to be practice. What is this trying to be? 1/n, right?
Yes.
If I took that away, that's 1/n. So this is trying to be. Can everybody see what I mean by that? That's trying to be if only that -1 was in there, it would reduce to 1/n, and that's a series that we know what it does.
Yes.
So what does this series do? Diverges, so therefore I want to find a floor.
Yes.
Officially, this is the word diverges now, okay? Just accept that. Looks like a signature, but that's okay. So what do I want? What kind of inequality do I want here? Here's my series I've been given,
Greater than or equal.
and I need this to be a floor. So I need this to be less than or equal to that. Yes?
Yes.
Okay. If I take the -1 away, that makes it become what? You can do it. If I don't subtract 1 from the top, it becomes bigger, yes? But I want this to be smaller, correct? Now here's the trick. You guys ready? What did I say earlier? You either take the -1 away or make it like terms.
Yes.
What happens if I try to put an n instead of 1?
2n. Zero.
You get 0,
Yeah.
which converges. Yes? So I really want you guys with me. Let me show you this first, and then I'll explain the other thing. So here's what I do. Instead of replacing it with a full n, I'm going to replace it with half an n. Is that still true?
Yeah.
Is that still true? It's true for n greater than 2, to be honest, but again, with all things with series, I just need it to eventually be true. You guys be really cool with this. Do you guys get this? Let's try this. If n is 3, what's that top?
A 2,
2. And if n is 3, this is 3 minus 3 halves,
which is less.
which is less. Do you guys see what I'm saying? Because I'm taking more away, so of course I'm going to be smaller. Yes? I need it to be like terms, but if I made it n, I get 0. I need you to see this. This is the other thing I want to focus on. If you make your changes too big, don't we know this diverges? We know it does. We're just proving it does right now, yes? We know it diverges, we just have to prove it. So if I put a 0 here, 0 is less than this, isn't it? But what does 0 do? Converges. Yes? Now listen, I really want you guys to. If your changes are too big, you could end up with a series that meets this requirement, but it converges. I need you with me. If I have a series that diverges, how many series are below that converge? Infinite number. Yes? I need you. If I have a series that diverges, doesn't the series converge? Yes, and when I do this, I'm doing this partial sums. I don't know if I've said that, but like this is the partial sums. They go to infinity. These partial sums, they go to something. Yes? And it's less than that one. You guys with me? If you take the changes you make too far, you could end up with a series that matches this condition, but it doesn't do the right thing. You could very easily make something that you want to diverge become a convergent thing if you go too far. Okay, I don't know if this makes any sense to you guys. You gotta be really careful. That's why I say the two changes you want to make are you take something away and it makes the inequality true, or you replace it with like terms. And the freakiest thing that could happen with that is this, where you might have to make it half of something instead of a full thing so it doesn't become 0. You freak everybody out. So what is this now?
1/2 n. It's 1 over 2n.
Who did I steal this from? Sungina Solar Swan. So this will be, you can do it, Jeff. 1 over 2n. This will be 1/2 n over n squared, 1 over 2n. And what does this do?
Diverges
Diverges y.
by p series.
P series, you can even say harmonic. P equal 1, not greater than 1. And so therefore our series
Has to converge. Diverge.
diverges by direct comparison test. We're going to be semi-formal in our write-up. Yes? I don't need a full proof. We're not writing this for the mathematical journals and so forth, but I still want you to identify exactly why things are happening. Okay. How we feel so far? That is trippy. It just is. Because you're not used to doing something like this. You have a lot of control here, but there are limits to that. If you go too far, it doesn't do what you want it to.
Okay, maybe. Maybe.
Okay. Not much more to say about that. Let me see. Do I have some examples on this thing? I think I do. Here we go. So So does everybody still have this sheet? All right, go ahead and try these three. Okay.
So this is
Oh yeah.
kind of like 1 over n. 3, 3. Sure.
I told somebody I was going to do the math induction today. I think I'll do it next week. I want to finish these up today, I think.
The stove. Induction stove.
Oh. And obviously, whenever you do this, you can work with each other if you want to. Total. What kind of series? Good. Geometric, and that's what these are good. They work really well with series and No, this is easy. This is not P series. P series would be x to a power, 1 over n to a power. This is
Is that good enough?
number
I feel like it
two,
should be.
the variable.
I just took away the thing.
So that's geometric.
Because it looks easier.
What is that?
Okay.
What's
That's
R?
a number 3.
Yeah, totally. So yellow converts into a funny C line. Good, you're good.
When it converges, you use the ceiling, and when it diverges, you look for the floor.
So if you, so just say to yourself, if you do take that away, the bottom becomes
Floor
bigger or
diverges.
smaller? Smaller, so the result becomes bigger. So I mean, just literally,
You know,
just take 5 seconds to do
I
it.
should write that down.
Write it down and then go, 2015. And if it doesn't, go back, instead of erasing it.
I guess you could do that.
Yeah.
Okay. So then you can make it county. Will it help? Well, I like think of it. I think about it in a graph. It doesn't actually work. I feel like that'd be a good way to check. Make sure you're not going too crazy. I'm not good with
Two things. You either take away the part you wish wasn't there, or you replace this part that's there. Well, see, that converges. So you want to find a ceiling, so this should be bigger than that. How do you make a fraction?
Oh, no, we can't get rid of an N
If I
everywhere.
make the bottom smaller, the result becomes
The
bigger.
first one? It converges, yeah.
So I want this to have a bottom.
I just looked at the example. It had one with the I was like, oh, that one said it converges.
The numerator is 2, 5, 10, 17, 26.
What about an N squared?
You need to end up with
Yeah.
something that cleanly converges. You need to end up with
I have no idea.
well, like
I don't know what 2 is trying to be.
It's trying to be 1 over N.
2?
You have to simplify it. Yeah.
Oh.
You just have to If you divide everything by N over 4, you basically get 1
Oh,
over
sure.
1
Thank you.
over N to the
Huh?
Fuck. Guys, how much units? How many units is this class?
4 tests
These are here.
and the final.
4 units. Damn. Damn, okay.
Because if you make the
know.
bottom
Yeah.
smaller, the whole thing is bigger.
Because it works out
That
to be.
is bigger than that. And you're-
That's what I got.
Converge, P series, therefore,
Oh, I thought you said 5 a 4-year-old.
now you gotta find the floor.
So,
So that's where you're like,
No, I heard that wrong. How old do you think I am?
21. just because of the way.
I don't know, how old are you?
I don't know.
Because you kept it like 6 times 1 plus 1.
So you're not over 25. No.
Well, you know, yes.
Well, I turned 2 and to the. And you would totally replace it.
Can't you just get rid of the one? Can't you just get rid of the 1 and the 2 and make it N3 over N4?
That's what I just.
Can we get rid of both?
I mean, when we plug it in, it gives us, except for the first number.
Like that would be easier. There are 3 unit classes? Huh? Which one is 3 units?
I said, I wish this one was 3, so I can drop it.
I can't drop this class.
Why? What does it mean when?
Because if it was 3, then I'd have 12 credits and it'd be SWA full time.
Oh.
No, that happened to me before, but
Oh no, like your she got down to
11. Because we talked about it last.
Pick up another class for the next half of the semester.
Yeah.
The second half of the semester.
We can do that. Come on. Okay,
If
guys.
there's no open.
This guy's
Just pick something like random that's like 1 unit or whatever it's leaving from the end or full time.
It's just, we don't know the
Any value in.
I clicked on self-service.
So if the bottom is
I clicked on self-service. I was trying to crash a nutrition class, but then I have 22 units.
and then I was
this is bigger than that. So therefore we need to.
I just saw that it was like it's multiplying by 6.
I thought it was not. I thought it was 19 or 20.
I thought the max was 19 and then I
But then I
tried
couldn't
to
make
after
this
that
look like what I wanted.
because it was over 18.
That's
I
why
thought.
it's-
Well, I think you can do it. I think you can do it as long as the class is like. You can keep it under 20.
You can put
I think you should try to keep it under 20, but it won't let you add another class if you're over. Yeah, you're over.
I remember taking 17 units from my first semester.
So if I make this square and this cube, I'm not getting close.
Yes.
It's so weird. It's going by some.
Because not all the
Does
classes.
that make sense?
Yeah.
It would look like
Oh, because it
1 over
was
2 and cube
for
minus the square.
Yeah.
level classes, so
That
it's
doesn't
not
look
that bad.
Yeah.
I need you in.
And then I was like,
It's like,
so
what I have
like,
on
no,
top
that's
of
not
it,
right. And now it's like, I
it's
gave
6
you
times
this,
1 and then
and
it's
then
that
Or
or 2
just
the next one for the.
I don't want to spell seating.
7 times
So,
1
so,
is
so,
the first one. Plus
oh,
one is
pick
7.
up a spring
Plus
class?
6 times
If I
2
just
plus
move
1.
shit, if I could just
I know where you
erase this minus
John,
1,
so
John, Union years.
if I.
No, that's no.
I make this
Okay,
like
so
third.
basically
Minus
you're building
combined,
like
and then it
electronics.
becomes-
With Legos.
Okay.
Yeah.
And
No,
then
it's
they kind
going
of just do like their little
And
rotation.
then they have motors, and the motors make it
If
move.
Maybe I was.
And then there's some classes where we code it, so we connect it to
Because
the
this
computer or tablet.
What's your major?
This is 6 plus.
In mechanical
I need to
engineering.
divide by something.
Is
Is there a way that like,
This
not
one's
volunteer, but like, is there a way that I can shadow you for like 1 day just to see?
I think I was counting for that.
I was
Then
about to
I
ask.
was 6. But anyways,
Like,
I guess that's the
Yeah, the bottom.
Wait, you don't have to? You don't have to?
Are you in a high school during summer?
Am I what?
You
Or summer in high school?
Because if
No.
There's
if
also a
it's
summer
been
session that's like temporary.
no matter, it wouldn't be full.
And that's a little bit better because it has crafts. So we do science projects, so like volcanoes and stuff like that. And
Actually,
like,
it's pretty hard.
and it's supposed to have an art project, a science project, and a Lego project. But I don't think we do.
Are you sure?
I don't think we do that. I don't know, like, we would ask the schools specifically because usually we would have TV testing, harassment testing, and all of those stuff because we're working.
So
with
it's temporary. And what's temporary work?
That's for summer, yeah. So we have summer sessions.
We're
Yeah,
looking at.
they're always
the quiz.
hiring.
We have 2
This
different
is for
sequences.
young engineers.
I feel like.
And they're all
compared
at
to
the
bottom
Bowling
one
District
is
and
way more harder than the top.
so most of the
What do you
schools
mean?
are
Sorry?
around here.
Oh,
Not this one.
Type it. And then.
well, no, you didn't have this one because these should be based on cubes. It was either based on squares or based on cubes.
That's what you use.
I really like it.
Okay.
It's most college students.
Not
because
those numbers.
They're not that
Is that-
many
so
hours.
it's
either
but
n
since they
squared
have
plus one, or
school,
was
they're
that
usually
cube?
fine with it because it's no
The
more than
cubes
15
goes
hours. a
1,
week.
8,
But summer we have
27.
more hours
Yeah.
So
because.
something like 2, 9, 28. That was 1 more than the cube.
Oh my
Yeah.
Just like
Yeah.
STEM.
It's after
What is
school.
that?
Yeah.
Alright.
It's after
I need to see that one.
Did we get number 3?
N squared.
What is number 3? Oh no, I forgot what number 3.
I think I was looking at different.
What is this?
Um,
How much charges are due? 5. to the power. It's gonna
No,
convert.
because it's 227
Sure.
before.
Guys, what is this? Just real quick, just out of nowhere, just what is this sequence? Cubes, yes?
Yeah.
These are the sequence of
Oh,
cubes.
I remember it differently. That's
Is
why.
there a relationship between that sequence and this one?
Yes.
What's the relation? If this is n cubed, this is
Plus
n
two.
cubed plus 2. Okay, all right.
Yeah, I think I remember it differently. That's why.
Is that okay? Do you guys see that? Do you guys see that? So, what are you learning now? You have to know your squares. You have to know your cubes. So that when you see a sequence that has them offset by a certain amount, you can identify it. You guys with me? So there was one version of the quiz where it was just one more than a cube. It was 2, 9, 28, blah, 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 blah. And the other version was it was one more than a square. You guys with me? I didn't see those, either one of those is harder or easier because we should all know our cubes and our squares.
I think I remember that. No, I
Okay.
just remember it differently.
You remember different.
Coming back to here.
It took me forever to get to the square.
Guys, is it, alright, listen. This is one of the trippier ideas because we're not used to having the flexibility we have here. We're not used to that. So there's two levels of what I want you to get. I want you to understand what you can do. And I want you to understand why you can do it. Yes? So the two things, just to make this as streamlined as I can, you either remove the thing you wish wasn't there, or you replace it. Why are we allowed to do that? Because I can construct any series I want to that does the two things. That either converges or diverges as I need it to, and it matches the inequality I need. If I make any series that does those two things, golden. What's the easiest way to do that? Because that's almost too much flexibility. Yes? So what do I do to help you out a little bit? I force you to only do one of two things, and that keeps everything kind of streamlined. So on this problem here, what do you wish wasn't there? That. Now, I want to point out one other thing. You could delete that, and what does that do? What does that resultant series do? Diverges. But do you see why n cubed is a more important guy here? Because that would converge. And so on one level, this problem is dumb. This problem is dumb. But this is all about proving something. We have to go into the proof already knowing what it does. So on one level, that already is kind of dumb. You already know the answer. You just have to show it to me, yes? So if that converges, I just made the bottom even bigger. So of course that converges. Are you with me?
Yes.
Now if I say use comparison test or something else, you better do that. And you better not just write me a little sentence like, well, I can tell, blah, blah, blah. That's good for you. You know the answer should be, now do it, minus 20. Are you guys with me? Not 20, maybe 30. So here, there are several levels to this, and I think you all get the idea of a series. If I know it converges, I want to get something above mine to tamp it down so it can't diverge. If I know it diverges, I want to get something below mine that diverges to force mine to diverge. What that looks like in practice is a little trippy because we're not used to doing this kind of math. If I start with this, by the way, what's this trying to be?
Thank you.
And so this is
Convergent.
convergent, so I want to find a ceiling. So right away I can write my inequality like this. So pretty cool with that. Bless you. Because I want this guy to be above where I start. Now, I started you off with a kind of a nice one here, right?
Yeah.
So this is where, because it's a division, inequalities get trippy. You got two layers to it, yes? If I make the bottom bigger, that makes the whole thing smaller. And if I make the bottom smaller, that makes the whole thing bigger. And I want the whole thing to be bigger, yes? So that in itself is somewhere you have to slow yourself down. to really, because it's not, we don't do that enough to really just be able to just not even think about it. You have to slow yourself down. So I want to make the bottom smaller so the whole thing gets bigger. So what's the most immediate way to make the bottom smaller while preserving the thing I know it wants to be? Take that away, yes? That way I made the bottom smaller. I'm dividing by less. So of course this is bigger than that. And then I'm basically there. This does what? Converges. Convergent P series. P equals 3 greater than 1, which means ours converges by, what is your problem, Jeff? How long do you have? Converges by DCT. Okay. Maybe. So what about the second one here? What's this trying to be? 1 over n. And in the process of seeing what it's trying to be, you've identified what you either want to get rid of or replace. So really, it's either remove or replace. That's the two things you can do to make the, and then you want to do it in such a way that the inequality goes the way it's supposed to go. This problem I love. Of course I love it, because there's two different things you have to do. So I start with this. Let's just focus on the bottom for now. Which way do I want this to go, by the way? I got to do this whole thing. This does what? So therefore I want to find a floor. So I want whatever's here to be less than or equal to this. So that is all stuff you could do at the beginning, very purposefully, get the inequality written down. Now you have that constraint in place. Now it's not this amorphous, just whatever you like. No, you have to match that inequality. So on the bottom, if I want to make my result smaller, I want to make the bottom bigger. If I remove that, I made the bottom smaller, yes? So therefore, I don't want to remove it. I want to do what?
2 ends instead of 4.
I want to make like terms, yes? You could officially just put n to the 4th. You don't have to put the 2. But you might as well leave what's there, right? Make it look a little bit more directly related. Do you guys see what I mean? So if you just say to yourself, if I did take that away, oh shit, it went the wrong way. Let me make it like terms instead. What do you want to do on the top? If I do take that away, does it make the result smaller? If I take the +1 away, is the result smaller? Yes, so then I just take the +1 away. Now somebody was asking me earlier, do you see how this is one step? What do I have to do now? Don't I have to simplify this?
Yeah.
Now that I'm simplifying it, I'm just going to put equals, because that's true. It just is equal. What is this equal to?
1 over 3n.
Yeah, 1 over 3n. Is that cool?
Yeah.
And is everybody really... well, I'll focus on this in a minute. That is 1/3 of the series 1 over n. And what does 1 over n as a series do? Diverges. So of course 1/3 of a divergent series still diverges. Yes? Finite numbers cannot save me or make me go to infinity. Okay, so it diverges. Therefore, because it's harmonic, I'll say it a different way. I'll say it's harmonic. Therefore, what does our series do? Diverges by DCT. Yes, sir.
If you chose to add by like terms in the numerator as well, it's still technically good.
If you do what?
Sorry, if you add a like term in the numerator, that's still good.
If you make it n cubed?
Q plus n cubed.
Yeah, I mean, if you make the 1 become n cubed. Is that what you're saying?
Yeah.
Then that makes the top bigger, yes? Which doesn't make this result smaller. If you put here 2n cubed, that's bigger than this, yes? Not smaller than this.
But what if it's reversed inequality?
No, let's just stick with this problem, please. I need you to see how that... Only one of the things is going to work. If I make the top bigger, then the whole thing's bigger. But I'm supposed to write something here that is smaller than this.
But it's still, but n is getting, because you still with the constant in the numerator.
Okay, here's the important thing. Your inequality would be the wrong way. And I know this is supposed to diverge. Do I need a floor or a ceiling then? I need a floor, yes? And the minute I do something that makes this go the other way, the proof is not satisfied. You've suddenly made something that's got a ceiling and when it's supposed to have a floor. I need you. So that's why the most important thing at the beginning is, do I need a ceiling or do I need a floor? If you need a floor, every damn inequality you write in that problem better look like that. The minute you do something that makes it turn the other way, nope. It's not guaranteed a floor anymore. Could be a ceiling, and that doesn't mean shit. If something bigger than me diverges, what do I have to do? I can do whatever the hell I want to. If this guy's like, I'm like, okay, I can diverge or converge. I mean, does that make sense? If I have something bigger than me that diverges, do I have to do anything? Do I have to go to infinity? Nope, I could go to wherever the hell I want to. If I have something below me that diverges, I don't care what I want to do. I'm going to go to freaking infinity. I'm going to diverge. Maybe. So there are two things. You need to do something that will make your result look like this, look like 1 over n. Maybe there's another constant. But everything you do has to maintain this so it does end up being a floor or a ceiling. Otherwise, you haven't proven a damn thing. So those two things have to always be true. I'm going in the direction of 1 over n. But everything I do better make the inequality point the right way. So I have a true floor, in this case, or a true ceiling. Maybe. How are you guys doing? I need this to make sense. Because on one level, if I can... Let me do this. 3. Is that greater than 1 plus 1? Yes. You guys with me? Is that less than 1 plus 5? You guys with me? And this is greater than, is this greater than 4? Is everybody with me? Now, there's a very wrong problem with what I've done here, yes? Do you guys see? Good, I see a few of you going like this. The minute my inequalities turn, this is not a true statement anymore. This can't be true. Because is 3 bigger than 4? Yeah. Do you see how that's effectively where I ended up? Yeah. How did I end up there? Because in the middle of all this shit, I went the other way. Mm-hmm. It's no longer guaranteed to be a floor anymore. It could be a ceiling now, and if it's a ceiling that goes to infinity, I could do whatever the shit I want to. I'm not forced to do anything. Do you guys see that? So at the heart of this process is forcing my series to do something specific. And I can only do that if I have a true floor or a true ceiling. Yes? So the inequality has to be that consistent way, or else I can't, is this floor to 3? No! Because it went the wrong way in the middle. Do you guys see that? If you, and trust me, I remember as a student, my teacher did not describe it this way. It was just so freaking amorphous, and we were all just like, let's just do something and hope. But it's not like that. It's literally, you either remove it or you replace it. With an eye towards making the inequality true. Yes?
So just to check, so in this one, it doesn't have to be remove or replace, it can be both, right? Because you added...
Yeah, and what I did, just to be really careful, was I did them one at a time. Yes? Mm-hmm. I think I did. Or did I do them? Oh, I did them both, didn't I? Damn it. But yeah, you're right. As long as the inequality remains pointing the right way. Yes. Okay. So removing the 1 on top made the result smaller. Making the 2 become 2 and the 4th made the bottom bigger. Both of those made the whole thing smaller. Okay, I like it. I meant to do that in multiple steps, and What about, I wanted to give you at least one problem that wasn't just a freaking P-series. And by the way, do you see, you normally see this for geometric or P-series? Obviously, this is what? Geometric. And what's the key thing about this geometric series? R is 1/5, which is less than 1, so therefore this converges. Therefore, I want to find a ceiling. Okay, let me stop for a minute. Is everybody cool with that analysis by itself, just that step?
Yes.
So if I say use the direct comparison test to analyze these series, that's the first thing you do for every problem is what is it trying to be? What does that thing do? I need a this. So it's trying to be geometric. Be more specifically, it's trying to be this. Or this even. Yes, it's trying to be this. That's convergent because R is 1/5. Therefore, I have to find a ceiling that will force mine to converge. So if I start with this, which way should the inequality go? Yeah, this should be a less than, so that whatever I write here is bigger. Yes? And this one is another, hopefully, easy one. If I take that away, the bottom becomes smaller, so the whole thing becomes bigger. So I can just take it away. Do you guys see what I'm saying? Do you remember you rule out U sub because U sub was easy? On these problems, you rule out taking the damn thing away because that's easy. If the taking it away makes the inequality go the wrong way, you go, oh shit, and then you replace it with like terms. This converges, blah, 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 so therefore this converges the direct comparison test, yes? Okay. So let me show you another like geometric, so you guys eyeing the clock. Oh, there's glasses. Just to show you. What you got, Jeff? Yeah, let's do. Yeah, okay. I'll just do this. Now, I want you to notice something. I'm doing this on purpose. Do I have to use direct comparison test for this? Why not? What do I wish wasn't there? And what can I do with it instead of replacing it or whatever? Take the damn thing out of the way. And then I have, and of course, what does that do? That diverges because R is 3/2, so it's bigger than 1. Yes? Okay, so what if instead I had this? What you got, Jeff? I don't know, man. So what is this trying to be? Trying to be 3/2 to the n, yes? And notice how we're being a little loose, but who cares? Because the heart of it is what R is. Officially should be 3/2 to the n minus 1, you know, and then I have to pull it, but who cares? All I need to do is identify what R wants to be. R wants to be 3/2. At the moment, I don't have a clean geometric, I got stuff in the way. So what does this do? Diverges. So therefore, I want to find a floor. So if I write this down, since I want a floor, I want my resultant to be less than, so it's underneath it, like a floor. If I take this away, what have I done? I made it bigger, which means I went the wrong way, correct?
Yeah.
Now, does anyone have a suggestion as to what I can do? And you're like, man, I've been waiting to tell you what to do. All right. What can I do here? I can't remove it, because it makes the inequality go the wrong way. Here's the thing you gotta be really careful about. If I make 7 to the n, I really want, this is kind of like what somebody said earlier. If I replace 7 with 7 to the n, did I make the bottom bigger? You can do it. Did not. I made it so much freaking bigger, yes. I made the bottom stupid big. So is the whole thing smaller than this now? But then my R is going to be like 3/7, basically. And the two things here still can't go together, which is the whole problem from the beginning. So making it 7 to the n is not making two things. It's not like terms. And you've made such a big change that it became convergent. So then I have a bigger, a smaller thing that converges. If I have a smaller series that converges, what do I have to do? Do I have to do anything? I can converge, I can go to infinity. This guy's like, hey man, and I'm like, whatever you want to do, man. Shwoo. Yes? Maybe. So, how do I make this like terms? You can do it. Yes? So I have 1 2 to the n plus 7 2 to the n's. How many 2 to the n's do I have down here? How many 2 to the n's do I have? I have 1 plus 7 of them. I got 8 of yes?
Yes.
Okay. By the way, I don't blame you for this. You don't see like terms like this too often, but I mean that's exactly how they always work. How do I make like terms? Whatever's there, I want the other one to look the same. Just have some other number of them maybe. And then this is 1/8 of that, and that doesn't matter about the 1/8. What does this do? Diverges. R equals 3/2 greater than 1. Diverges. So therefore ours does what? Diverges. We got a floor. We got something less than ours that diverges. Therefore we must diverge by the direct comparison test. Okay. I'll let you guys have this look on your face like. I don't like that. Let's do it. You guys are going to enjoy what's called the limit comparison test. The thing that happens in a lot of mathematics, if there's something you like, it doesn't work as much. So there are places where the limit comparison test fails and you have to go back and use the direct comparison test. Limit comparison test is much more straightforward than this, but it doesn't always work. That's always the trade-off. Alright, so that's enough. I need some time to get ready for my next class anyway, considering this morning was all about other things. So I'll see y'all next week. Don't, what's happening next week?
Another
2 more quizzes! Yes!
but then
Okay.
after spring break.
Quick question.
Yes.
I just look